Hello, class. Welcome back. Today, we're going to start chapter 8, right? Hypothesis testing. So this section is going to be related to where we left off, right, in test 2, right? Solving for our z values and more of that, right? And less of the probability portion of it, right? For 8.1, well, we're going to get introduced, right, to writing things in alternate and alternative and right accepting the null hypothesis, right? So for 8.1, this is a chapter that I really right really need you all to um to read, right? Know the definitions and read. It's mainly going to be the foundation for the next for sections 2, 3, and 4. So, and of course, at any point you have any questions, feel free to contact me by email. Right. So let's go ahead and get started. Right. In test 1, right, we got introduced to the null hypothesis by definition. Right. I believe we had 2 problems during the final. During the last final questions of exam 1. Right. The definition states that the null hypothesis, symbolized by H naught, is a statistical hypothesis that states there is no difference, right, between a parameter or a specific value, right? So, right. So let's go ahead and get started, right? Let's go ahead and how do we write things out, right? One thing that we're going to see a lot in the next few sections are going to be one-tailed test and two-tailed test, right? A one-tailed test is used when the null hypothesis should be rejected if the test value is in that critical region, and similarly, right, for the two-tailed test hypothesis, two-tailed test is used when the null hypothesis should be rejected if the test value is in the critical region on either side of them, right? So let's visualize something, right? The definitions we're going to be using in this class, right, are going to be a critical value and a observed value, right? Okay, so let's say, right, so here I have my graph, right? And let's just say that you end up finding a z value, which is your critical value. And this is critical. It is important, right? You're going to find this value, right? Let's just say right here. Right? This ends up being your critical, right? You mark that it's either going to be on the right of the graph, right? And you're going to shade everything leading to the closest tail, or you may get something like this for a one-tailed test, right? You're going to get a z value and shade it. All right, maybe somewhere like right there. All right, and where this is your critical value. Critical value. So for this one, you may end up getting a z value that's like, let's just say your critical value is 2.71. And for the second example, let's just say it's negative 3.01, right? So these are the 2 different types of examples, right? Right. So the critical is going to mark, right, a boundary, right? So meaning you're going to do some work and you're going to have to find an observed value, right? You're going to find an observed value and you're going to make an observation. Is the observed value behind that point, or is it in the critical region, right? Or is it in the critical region? So one that's outside, one that's not in the critical region would be something like, let's just say z equals 1.2, right? Because 1.2 is to the left of 2.71, right? So let's just say that's right there, right? That is not in there, right? If there's something in here, right, what would be something considered something in there? That'll be, let's just say z equals 3.08, right? That is in the critical region, all right? It is in the critical region. All right. So, right, and whenever you're dealing with it, right, you're either going to reject the null hypothesis or fail to reject the null hypothesis, right? So, if your observed value is in the critical region, reject null hypothesis, all right? So in other words, if you were to go ahead and do some testing and you find that, and you were comparing this critical, right? Z equals 2.71, and you compared it to your observed value. Let's just say your observed value was 3.08, right? You would say, hey, my observed value is in the critical region, therefore I would reject my null hypothesis, right? Right. If the observed value is not in the critical region, fail to reject. Right. This terminology here is what I will be looking for in the exam, right? So a blue case would be like this, right? Like that one. And a pink case like that would be for this one, right? For that observed value. Right. So let's go ahead and do the second example, right? You're dealing with another one-tile test, and you're dealing with values to the left, right? Give me a value, give me an observed value that's not in the critical region, so not in that shaded area, right? So that could be what, negative 2.99, right? It's not in that critical region, right? Right, and a value that is in the critical region would be something like negative 3.141, right? Right. If your answer was, if you're comparing this critical region, negative 3.01, and you compared it with negative 3.141, right? You would, if observed value is in the critical region, you would reject your null hypothesis, right? That's pretty much what we're doing here, right? Right, so these are for one-tile test, right? These are for one-tile test. You're also going to have two-tile tests, right? Where, let's just say your observed, let's just say, no, your critical value, right? Your critical value ends up being something like 1.25, right? Since it's a two-tile test, it's going to be plus or minus 1.25, right? So meaning you're going to draw your graph, right? Your symmetric bell curve. You're going to do 1.5 here, and then you're going to mark negative 1.25 there. Right? I'm going to go up here, and then I'm going to go up to here, meaning I'm going to shade everything to the left of the negative one, and I'm going to shade everything to the right of that. Right, so these are your critical values, right? And then you're going to get your observed value, right? You're going to get, you're going to see your observed value. Right, so let's just say an observed value I got was 1.30, right? Where's 1.30? 1.30 would be inside here, right? So let's say, yes, observed is in critical region. Therefore, right, these three dots, therefore, reject null hypothesis, all right? If, let's just say, the observed value you found was instead negative 0.11, right? Well, this is in the non-critical region, right? So you would say, no, observed is not in critical region. Therefore, fail to reject null hypotheses, right? Fail to reject null hypotheses. Okay, so what we're mainly going to be doing here is learning how to, it's going to be step one in these future problems, right? It's going to be step one in these future problems, meaning you're going to be giving a sentence, you're going to be reading the question, and you have to give the alternative hypothesis, and you need to give the null hypothesis, okay? generally what I like to do is to start is with my H1, right? My H1 ends up being my alternative hypothesis. And let's go ahead and read the question, right? The average number of monthly visit sessions on the internet by a person at home has decreased from 36 in 2009, right? So it has been less than 36, right? So what you do there is you read it how you would algebraically, right? And you would say, hey, my mu value, right, which is right, my mean, is less than 36. All right, and after you find your alternate hypotheses, you go to your null hypotheses, right? Your null hypotheses, right? And you would state mu, then your alternate hypothesis will then have to be 36. All right, it would have to equal 36. All right, let's go ahead and do our next value. All right. So I have for the following conjecture, right? State the null and alternative hypotheses, right? And again, right, we need to know how to write these because this is going to be step one in all these problems that are coming up, right? All these problems are going to require probably 5 steps. We're currently covering step 1, all right? And this is what's going to be required for the exam. For the following conjecture, state the null and alternative hypotheses. The average income of accountants is less than that given value. All right. So again, right, what I'm going to go ahead and do is write my alternative hypotheses, right? That's H1 such that my mu is less than that value. Meaning my null, and it's up there, right? I'll go ahead and make that bigger for you all in a bit. 1 second. My null hypothesis, therefore, will have to be H naught such that my mu is 97. All right. And the definitions are, let's see here. Awesome, right? That's exactly what we have. All right, and then we got more definitions here for you. All right. Hopefully by now you have already read the book. My apologies for this. My apologies for that. All right. Now, hopefully, by now we should have already read the book, right? If not, you can go ahead and pause the video and read the description, right? But what I see that mostly helps is always starting with the alternative hypothesis, right? Eventually, right, this here is going to play a big role in what we're going to be doing. All right, you're gonna be it's right, and by definition. So this is something you may want to write on like on a cheat sheet or something, or add this to your formula sheet. All right, on the side. All right. So you're going to be giving an alpha value, and you would have to you're going to do some work to find a p-value, all right? And comparing them both is going to tell us a lot, all right? Comparing both of these is going to tell us a lot. If your p-value, right, a numerical value is less than or equal to, all right, to an alpha that's going to be given to you, you're going to reject the null hypotheses. Right, and in the other case, right, would just be greater than a, right, you failed to reject the null hypothesis, right? Or in other words, you do not reject the null hypotheses. All right. How you be, let's see. All right, I'll go ahead and mention something right now, all right, just to go ahead and, right, if you find out that if your p-value is less than or equal to a, or if, so it can happen with this, right, with when your p-value is less than or equal to a, or if your observed is in your critical region, right, this is within, right, if it's within your critical region, right, you answer yes. You answer yes, meaning there is a difference, right? And you reject the hypothesis, all right? Right. this goes back to the null hypothesis, right? So the null hypothesis states that there is no difference between given data, all right? So if you reject the null hypothesis, that means there is a difference between your data, all right? So if you need more time with that, just again, your null hypothesis states that there is no difference between data. So if you were to reject that, all right, if you were to throw that away, then that means there is a significant difference between your data, all right? So that's where that's coming from, right? Again, if your p-value is less than or equal to your alpha, or if your observed value is inside your critical, you're going to answer yes, meaning yes, there is a significant difference in your data, and you're going to reject the null hypothesis. If your p-value is greater than alpha, right, or if your observed is not inside the critical region, so you would answer no to the question. You're going to be asked a question, and you have to determine is there a significant difference or there no significant difference. You would answer no significant difference. So you fail to reject or do not reject no hypotheses. All right. All right, and all of this is going to make more sense, but this page here is golden. This page here is golden. Okay, so go ahead and do go ahead and take care of 8.1, and I'll go ahead and see you in 8.2. Thank you.